All right, people. Greetings. Hope everyone's well. Strap in for the review. I think I'm going to try and do this in two 10-minute videos, keeping it simple. This first problem is all about transformations. We talked about every circle is similar to every other circle, and the scale factor is the ratio of their radii. That's it. That's all you have to realize, right? That's the segment that's changing. So I'm not going to spend too much time on this, but if you take a look at this problem, circle A is the smaller one, centered at 1, -5, radius of 2. B, center 5, 2, radius of 5. Trying to prove they're similar. What steps does she need to do? Well, the first thing you have to recognize is what? It needs to go up and over. Well, how far does it need to go up? How far does it need to go over? And look at the radius sizes, 5 and 2. All right, so it's getting bigger going from A to B, so it should be greater than 1, so 5/2. And our translation is up 7, right 4, which in vector notation is this, or coordinate notation is that. Pretty simple stuff. The hardest part is getting the scale factor right. Remember, smaller, a reduction, it is less than 1, and enlargement, it's greater than 1. Moving on. What's the definition of a circle? Well, a circle is a flat object. It's in a plane, right? So right off the bat, space, that's a sphere, right? A sphere. That's not what we want. We want the set of all points on a plane that are equal distance from the center point. That set of all points is called the circumference. All right, these are the formulas. This is really important. You have access to these, memorize them, have a note card, whatever it is you need to do. All right. Thank you, Ms. Cobb. What are the angle relationships here? Well, we know that we have vertical angles in the middle. Do you guys remember what that angle relationship was? It had to do with the arc lengths. Right? What was that? It was half of the sum, also written like that. So you take the two arc lengths, add them up, cut it in half. Okay? Those were two intersecting chords, not on the center point. What do we have next? We have two tangents. Well, what was this? Remember, big arc minus little arc. That's what you want to remember. And cut in half. The big arc, EHG. And then the little arc, EG. You subtract, cut in half. Two tangents, right? How about this next one? What do we have? We have two secants. Same exact thing. Take the big arc. Take the big arc. Subtract the little arc. Cut in half. Okay? How about the final one? We've got a secant and a tangent. It was the same thing. Take the big arc. Subtract the small arc. Cut in half. Those are important to know, people. You got to know them to be successful. Like this problem, let's take a look. What's it say? What's the measure of chord CD? We're looking for this distance right here. So we need to find out what X is. Well, what's the first thing you can tell me about this problem? Well, BD and CE are diameters, right? They go through the center point A, which means those vertical angles must be congruent. That means that not only are the arcs that they intercept congruent, but also the chords. Oh, I just made like a TIE fighter. Anyways, so if the chords are equal, we set the algebraic expressions equal. Solve, subtract 2x from both sides, add 7 to both sides. And you get what? 2x equals 10, which tells you x has to be 5. And when you plug 5 back into the original, you get 13, which you see is the answer. Best answer of all, 13. So the angles intercept the chords, which intercept the arcs. All that stuff is congruent. Well, chord to chord, arc to arc, angle to angle. All right, moving on. All right, so I did a little bit of pre-work on this one. Find the measure of angle BPD. Not BDP, that's Boogie Down Productions, 80s hip hop. Check it out. Boogie Down Productions, KRS-One, legend. Anyways, angle BPD, where is that? That's this, right? This guy. So I cut out secant BP and PD. Okay, to take a look. Well, what does that tell us? We just looked back on a couple slides before this that we know that it's what? Big minus small cut in half. All right? Well, what do we know? We do know that this is 62 degrees. But we don't know what BD is. So in order to get angle P, we need to get BD. Well, what else can we do to bring BD into the equation? Well, we go back and we take a look at the equation and we cut out these intersecting chords. A couple frames ago, we determined what? That BED has to be equal to the sum of those two cut in half. Well, let's go back to the original problem. If that's 45, that has to be 45. 45 and 45 is 90. The whole thing has to be 360. 360 minus 90 is 270. Cut in half, meaning this has to be 135, and this has to be 135. Well, that means this has to be 135. So we know angle BED. Now we can take this other relationship, right? These two arcs that are summed, and we can actually substitute in some information, and solve. Well, what is that? We know that BED is 135. I'm going to multiply both sides by 2 to get rid of this. Well, that's 270, which has to equal BD plus AC. Well, I know AC. Oh, wait, do I? I know AC. It's 62. So what's BD equal? Well, after I subtract 62 from both sides, I get BD is equal to 208. Well, now I can go back to my original equation all the way up here, 1/2 208 minus 62. Well, 208 minus 62 is 146. And half of 146 is 73 degrees. So from right here, you get half of 146. That's how you do that problem. I'm going to stop here because we're approaching 10 minutes. Make sure you master these frames and know how to do these problems. Good luck. Be safe.